Thank you all for inviting me to this CNCF session. My name is Raymond Jong. I'm a solution architect working at Isovalent. And today I'm going to talk mainly about Cilium and also about eBPF and how Cilium as a CNI can enable you to be cloud native, securing and providing network and observability to your container workloads. Some of you may have heard about Cilium or eBPF and what it can do. The goal of today is to leave you with how it works, what it can do, some pointers to, how to get started, where to ask questions. For this session specifically, I'm already behind schedule, I guess. Please ask your questions in English, please, in the Slack channel, so I can answer them after this session for you. Depending on the time I have, I can do it during this presentation. Otherwise, I will do it offline. And if we have sufficient time, I might have time for a bit of a demo. But let's see where we are. So for today, I will start with what is eBPF. Some of you may have heard about it. And it's basically software which makes your kernel programmable without requiring you to upgrade your kernel. That means that you can write mini programs based on certain events where you can do amazing stuff with it. Basically anything related to disk activity or networking or processes can be are events which you can basically write business logic against in eBPF programs. So today, obviously, we're going to focus on networking with eBPF because Cilium is an eBPF-powered CNI. So eBPF runs custom code in the kernel, and every kernel is event-driven. So, for example, when a packet arrives on the network interface, the kernel triggers an event to do something with that packet. Basically, in user space, you can write programs which leverage eBPF to do things with those kind of events. And that opens a lot of areas for, let's say, packet inspection, tracing, observability, security, and such. So eBPF programs run based on events. So this is a slide of examples. I want to focus on the right half of this example, where when a pod or program sends network packets, there are different attachment points where eBPF can do business logic or some certain things as a CNI for you. So, for example, it can inspect a certain process connect or a certain TCP retransmission or sending the actual network packet. And based on those events, we can attach business logic and can inspect the data of that events based on your requirements. So this is basically an introduction of Cilium, because Cilium is eBPF powered. So all these custom built logic in terms of networking as a CNI is used by Cilium. So Cilium is an eBPF powered container network interface. It's open source and provides security and observability and connectivity for your container workloads and is fueled by eBPF. So as an overview, for example, in your Kubernetes clusters, you are doing things like network policies, services and load balancing, bandwidth management, flow, policy logging, operations, security metrics. And Cilium enables those features as a CNI and make sure your pods have connectivity. But using eBPF, we can actually inspect, manipulate, trace, and secure any traffic leaving and arriving at your pods. And amongst those features I'm showing right here, we're going to look a bit further in this session. Some more detail of the use cases in terms of container networking, obviously routing, overlay networking, also IPv4, IPv6, Net4.6 and 6.4, and multi-cluster routing is supported. We have built-in layer 3, layer 4 load balancing, kube proxy replacement, and north-south load balancing using maglev. Also, service mesh. You may have heard that Cilium has a beta program creating a new service mesh, which is sidecarless, which we are going to talk a bit further today as well. Security is a huge use case. We provide identity-based network policies, Cilium network policies, which are API aware, so supporting HTTP, gRPC, Kafka, Cassandra, and such. DNS aware policies, out-of-the-box encryption using IPsec, WireGuard, TLS termination, and dynamic envoy injection. And in terms of observability, we have a built-in product called Hubble, which I'm going to show today later. And we can also provide flow logs, metrics, service map UI interface, which enables going on inside your namespaces in terms of traffic. And we can export metrics for OpenTelemetry-based implementations. Some of our users, Google uses Cilium for GKE environments. So it's built in GKE, it's built in CentOS. It's also, you may have heard about Google's data plane version 2. Well, that's basically based on Cilium. Datadog uses, for example, Cilium for multi-cluster load balancing across their clouds, IP VLAN support, ENI support. Bell in the United States uses it for, their telco use cases using Cilium for their edge clusters. And these are just a few use cases of our current Cilium users. So let's look a bit further at the actual networking use cases. A CNI provides, connecting your network devices, provides IP address management, provides connectivity within your nodes and between your nodes, either using routing or tunneling, and some kind of kube-proxy implementation, which allows for services based on IP tables and IPVS, and service discovery of your endpoints. What Cilium does in this sense is an eBPF-powered CNI, which runs as an agent on each node, and based on the settings you provide during the installation, can do a number of things which are eBPF-powered, and that has a number of advantages in terms of scale and performance. So it's an eBPF native data plane and can provide a kube-proxy replacement, which is very beneficial for performance, as I will show you later. So let's look a bit at Kubernetes services. As you already may know, is that a Kubernetes service is a way to provide connectivity for your apps to, for example, for a front-end app to have connectivity to a back-end app. Containers are ephemeral, they come, they go. You may scale out or scale down your containers. And using a service of type cluster IP enables you to give consistent connectivity within your namespaces for your apps. And obviously, this is in Kubernetes world at scale, provides high churn, will involve a lot of changes. As you have more namespaces and more services and more pods being deployed in your environments, that means that there are a lot of churning going on in your environment. And actually, kube-proxy for Kubernetes services using IP tables or IPVS. And changes for a given service are not atomic, meaning that if you are adding pods to a given service, basically the IP tables are getting reprogrammed, and packets being evaluated for services have to go through IP tables. And at scale, this is a performance problem because at large clusters of hundreds and thousands of nodes with numerous of servers, obviously a certain reprogram of a service, meaning a change of IP tables, will take a lot of time because of that high churn. So eBPF-based kube-proxy replacement gives a solution for this, because eBPF-based kube-proxy replacement is per CPU hash table based, right? So instead of a linear list where all rules have to be replaced as a whole, we keep a per CPU hash table of all the services and the related endpoints. And we store that in so-called BPF maps. What that means is that if you add a service or endpoints are getting added or removed for your given service, we just have these atomic changes of those endpoints and just need to update that hash entry, but don't have to reload the whole map. So that's very performant. And obviously also for things like network address translation, firewalling, this CPU hash table has a lot of performance benefits for each packet flow being processed through your CNI. Cilium also provides out-of-the-box load balancing. So in typical cloud providers and CNIs, you need to rely on a cloud provider implementation of a load balancer. So when you create a service type of load balancer, your cloud provider or your external software or something like Nginx can help to create a load balancer for you. In other words, it's not out of the box that you have any connectivity in a CNI. With Cilium, that out-of-the-box load balancing is included. So we provide layer 4 load balancing and layer 7 using Envoy, but for now, layer 4, in case of layer 4 load balancing, we provide out-of-the-box load balancing, which can also advertise using BGP specific IP addresses allocated to load balancer IPs to the external network and can attract traffic to that load balancer IP. We also support maglev and direct server return and express data path acceleration using eBPF to increase the performance of throughput towards your endpoints. Cilium has a lot of adoption in different platforms and has perfect integration in a lot of those. So if you want to try Cilium, you can start Cilium on your Minikube or Kind clusters. Cilium is also supported on self-managed Kubernetes environments. The main requirement for Cilium is that you have a fairly recent kernel. And these days, I think we rarely see customers having a kernel which is not yet supported for eBPF. And obviously, all the cloud providers support is there. So for Amazon, Google GKE, and Microsoft AKS, we support Cilium running on those clusters. So, for example, at a specific use case is for Alibaba, AWS, Azure, and Google is that we also have native cloud support in terms of ENIs, right? So in this example, when you run clusters on AWS, you may want to have native routing mode because you want to leverage your security in AWS to secure the workloads in your cluster. So in this case, the Cilium node CRD the operator can interact with Amazon Web Services, making Amazon operator responsible for creating your ENIs, allocating IP addresses, after which the Cilium agent can create and associate specific IPs with endpoints and make them available to the network. So depending on your requirements, you can do different things. It's also compatible with all other CNIs. So if you want to have CNI chaining, that's perfectly possible as well. That means that you can have another CNI responsible for, doing the device plumbing, the IPAM, and the routing, whereas Cilium is being leveraged for load balancing, network policies, encryption, and multi-cluster and visibility. So yeah, depending on the settings you need, and you will enable that and you move forward. Cilium by itself, if you want to do routing and overlay with Cilium, Cilium supports obviously overlay using VXLAN by default. You can also enable Geneve as an overlay protocol, but also in certain cases you may need on-prem native routing or some kind of hybrid configuration where you have a flat layer 2 and an external IPAM. That's perfectly fine too. Another great feature of Cilium is that the possibility to connect multiple Kubernetes clusters together, and not only on-prem, but also on your clouds, right? And on different clouds as well. So using cluster mesh, you can, for example, have a Cilium-enabled cluster running on AWS, whereas another is running on Google Cloud. And you can connect those together and create high available services for the workloads in your clouds. So using cluster mesh, you basically connect them together, provided you provide the IP connectivity, the ports are being opened between your clouds, most likely using some kind of VPN solution. And that means that in each cluster, you can create a service with a specific annotation, which basically triggers Cilium in each cluster to add those endpoints in a given cluster to be added as an endpoint for that service. And that means that in this example, when in the right cluster, the backends fail for whatever reason, the service is still available and the application will still remain available because we can fail over the traffic to the other available cluster. Another use case of cluster mesh is where we have multiple clusters connecting to a shared services cluster. So that could be, in this case, a services cluster where we keep our secrets with using a vault kind of service. And one or more clusters want to use that service to interact with. So using cluster mesh, you can connect multiple clusters to that shared services cluster and create services in a cluster to reach that service. And the endpoints in your shared services will be automatically be advertised on your clusters and reachable. Let's move on to security. So obviously, Cilium supports native Kubernetes network policies. But if you're thinking about Cilium in general, we really recommend to look at Cilium network policies, because those open up a lot of opportunities for you to explore for the specific solutions for security. Cilium provides identity-based security, which means that based on the workloads you deploy in your Kubernetes cluster, based on the labels you attach to your pods, Cilium creates identities, unique identities based on that combination of labels. So, for example, if you have a front-end and back-end pod, labeled front-end and back-end, those will be unique identities associated with all associated pods which have that label. And what Cilium does with that labels is, when you create, obviously, Cilium network policies, we can use that identity to secure traffic between your workloads. So in this case, the front end wants to reach the back end, and the Cilium agent has attached that identity using BPF to that front end. And that identity is encapsulated in the payload of that packet, which means that on the other side, BPF can be used to verify that identity and to match it with a Cilium network policy or security to allow or deny that traffic. And using BPF, that's extremely powerful and highly performant compared to IP tables. Cilium also supports API-aware authorization, meaning that typically CNI supports, obviously, layer 3, based on source IP, or layer 4 based on a specific port. But Cilium can also support specific HTTP calls to a specific endpoint. So in this example, you can allow only an HTTP GET call to /public for a given backend. So you can really have layer 7 narrowed down security for your endpoints. And this also applies for things like Cassandra, Kafka, gRPC, and others in the future, which will be enabled and will be visible and can be filtered using Cilium. So this is an example of a Cilium network policy where we match the labels of the app Cassandra, and we only allow ingress, the port, the protocol, but more specifically, the protocol, layer 7 protocol, which a specific query action and query table is being allowed and nothing else. Cilium also provides DNS-aware policy, where we can only allow specific requests to specific DNS names. So this is very useful, obviously, in hybrid and public cloud implementations, where, for example, we see a lot of applications interacting with, for example, S3 buckets in AWS. Those IPs behind those buckets change all the time, right? So you really want to filter on DNS records. So that means that you create a Cilium network policy only allowing to access a specific fully qualified domain name. And we also support regex and wildcards in that sense as well, to be allowed to access that endpoint. So what typically means is that a front end does, for example, wants to reach www.mydomain.io. Well, this will be a call to kubedns, and using Cilium eBPF powered programs, we can see that request and we can do actions based on the request. So in this case, we allow it, and we return kubedns is returning that IP. That means that the HTTP request will actually be able to reach that. Everything else in that sense from front end is being denied. So a bit about matching capabilities. So this is about the identity and the matching of those identities using Cilium. So we match against pod labels or namespace names and labels, service accounts, service names, or cluster names. Like I said, fully qualified domain names, CIDR blocks with exceptions, but also in case of cloud providers, instance labels, VPC, subnet names, tags, security group names, and inside a cluster, logical entities. So everything inside a cluster, everything outside a cluster, and localhost. And this can be very useful, for example, when you really want to do microsegmentation, you typically want to allow, obviously, everything in the cluster to be allowed to contact kubedns, obviously. So that's a great example of where we use that entities to make that work. Then moving on to observability, Cilium includes a component called Hubble. And basically Hubble consists of three main pieces, which is the UI, the CLI, and the metrics. And Hubble enables you to see the current traffic inside your namespaces and coming in and out your namespaces, and gives you visibility and also the option to export your metrics to, let's say, Grafana and Prometheus. And I will show a bit of those examples now. So this is the CLI, so Hubble CLI. So you basically can do a Hubble observe command with which you can follow, and then, for example, based on a label class equals Xwing, you can monitor everything related in terms of flows to that specific label. It attaches different metadata. It has the internet headers, the IP headers, ports, obviously, but also layer 7 HTTP, DNS, and Kafka examples. It shows Kubernetes pod names, service names, worker node names, and DNS calls if available. Keep in mind that by default, we do layer 3 and layer 4 filtering with Cilium. It only triggers layer 7 filtering once you create specific Cilium network policies, which has layer 7 components in it. And obviously, that's there for performance reasons. And obviously, Cilium data as well, like the endpoints and identities I talked about earlier, and the drop and verdict matches. Cilium also provides a Hubble UI, which is basically a user interface which you can select your namespaces and see what kind of traffic flows are going on in your namespace. Also, if there's ingress and egress traffic from and to your namespaces, it will display that using Hubble UI. And this is just one example of a jobs demo app where you can see all the components which talk to which component. And this really helps you to understand your applications running in your namespaces, or anyone looking for how to secure that specific application and traffic within that namespace. And this is a great starting point for basically creating the Cilium network policies and to secure that application. If we have time, I will show a little demo of that interface as well. With regards to service mesh, so we for service mesh, which means service mesh which is sidecar-less. So this has a lot of benefits and accelerates the path to your endpoints. So a typical service mesh with traditional networking means that when you send or receive a packet, it basically goes through the node interfaces and TCP IP stack, then it reaches the pod, and then it needs to go through the envoy TCP IP stack before reaching the actual app TCP IP stack. With Cilium-enabled service mesh, which is a sidecar-less model and has eBPF acceleration, we basically can receive the traffic from the TCP IP stack on the node and then directly forward it on the socket level to the socket of the actual pod. And that's eBPF-powered maps, which provides rich connectivity for a specific endpoint. And because it's sidecar-less, that means that the envoy is actually embedded in the agent on the node. And that means that instead of spinning up an envoy sidecar for each and every container, we have a sidecar-less model. So you save a lot of resources in your Kubernetes cluster. And in terms of acceleration, we do see 3.5 times performance improvement compared to an IP tables or traditional based sidecar based service mesh. So that was a lot of stuff and features I shared. So I do hope if I have a little bit of time for a little demo, if the organizers can let me know if I have such time, 5 minutes or yeah,
course.
cool. Okay. Before going to the demo, I mean, if you want to know more about Cilium, go to cilium.io. If you want to learn about Cilium, go to the Learn site, and there are interactive Cilium introduction and live Q&As, which are weekly, which you can book a seat, and Thomas Graf, a Cilium co-creator, will answer your questions. There are also monthly community install fests based in Europe and Americas. So basically in that session, you will set up Minikube, set up Cilium, and see how it a bit works as an introduction. And obviously you can explore the documentation and tutorials yourself. So the tutorial or the demo I'm going to show now is based on one of those tutorials on that site. So basically you can try different things there for yourself. And for more information, there's also a Cilium dedicated Slack channel, obviously a GitHub repository. If you're running Cilium, running issues, have questions, you can ask them there as well. And the website and Twitter handle for you to explore as well. So with that, I'm going to move to the demo. So what I wanted to show a bit more here is in action the observability part of network policies. So first of all, I have Cilium running here in my environment. This is a Google-based environment. A GKE cluster, just 2 nodes, or 3 nodes, sorry. And the Cilium is also already installed in sake of time. We have a Cilium CLI, so I can do a Cilium status. And I've installed Cilium and it's running and operating fine. And I also enabled Hubble and the Hubble UI and the relay, making sure that I can interact with the Hubble CLI, but also I can enable the Hubble UI. And doing so, I basically do a Cilium Hubble UI, and this will open a new browser in my computer. Takes a bit. And basically, this is the homepage of Hubble UI, and this will list your namespaces. So I have just used the default namespace, but you can also inspect, for example, Cube System and see what's going on there. So as you can see, it provides a live view of what's interacting with the Cube System namespace and all the flows happening as we speak. So as you see below, we can inspect that traffic specifically. For this demo, I just deployed a simple application in the default namespace. If you look at the Cilium documentation examples, you will see a lot of Star Wars-based themes. So this is an application using basically the concept of the Death Star and a TIE fighter and X-Wing wanting to access the Death Star. So let me first generate some traffic to get the Hubble UI moving. Bear with me. So basically I'm doing a curl from the X-Wing and I say I want to land at the Death Star. And in this case, it's allowed and the ship is landed. So this will trigger, obviously, as you can see, traffic, and the Hubble UI will display that traffic, showing that the X-Wing is allowed to enter the Death Star and to land its ship there. Well, obviously, this is not what we want, right? We only want to allow a TIE fighter to land. So also for completeness sake, I will also show that the TIE fighter is allowed to access the Death Star, as you can see. And basically, the Death Star is just, a deployment with a service, as I will show here. Now, I talked a bit about Cilium network policy. So I've prepared a Cilium network policy based on the Cilium examples here. So quickly, in sake of time, I will show the layer 7 network policy. This is basically a simple rule allowing access from only, organization empire with the class of Death Star, or basically that's where we apply the policy to. And it's only allowing from endpoints matching the empire on port 80 on protocol TCP to do a HTTP method post to request the landing. Okay, so we only want TIE fighters to be able to land on the Death Star and nothing else. So let's apply this layer 7 Cilium network policy. That's now applied. And now let's see if from the TIE fighter I can still land. And that's allowed. I can see all things being forwarded still. And let's see from the X-Wing point of view if I'm allowed to land. This takes a bit longer, so it looks like it's being denied. And as you can see here, Hubble UI already identifies the traffic and shows that X-Wing has the verdict dropped and the traffic is dropped, so we're not allowing that X-Wing to land on the Death Star. Also quickly show the CLI. So Hubble Observe is a command where you can observe traffic. So in this case, I will observe traffic from the namespace default, and I want to follow it. So on the live view. Oh, sorry, I need to open that port. So I'm going to stop this. Cilium. Hubble. Going to port forward Hubble. So this is basically enabling the relay, the Hubble relay to interact with it on the console. So then I can do Hubble Observe. And now I can do that traffic again. So again, the TIE fighter. And see, it's all allowed. It's being forwarded. You can also see here the layer 7 request, the HTTP response, right? So we have visibility in what exactly the call that pod is doing. And let's try now for the X-Wing. And as you can see, using Hubble CLI, Hubble Observe, we can see it's policy denied and it's being dropped. That concludes the demo and the presentation. So if you have any questions, please post them in Slack. I'm not sure if I have time for any questions live. Otherwise, I will respond offline. Thank you.